Hi everyone. Today we're going to learn about volume and what happens when objects sink or float in water. We'll look at pictures, we'll use real examples, and I'll ask you to think and talk with me so we can figure things out together. By the end of this lesson, you will understand how to measure volume and how water helps us learn about objects that float or sink. Let's get started. What is volume? Volume is how much 3D space an object fills. It's measured in cubic units such as centimeters cubed, inches cubed, and feet cubed. If a shape has 30 centimeters, it could be made of 30 unit cubes packed with no gaps. Looking at this picture, you when finding volume, the easiest way and the most basic method is to count the unit cubes. Here in this picture are some unit cubes. Each little cube is 1 cubic unit. That just means that it takes up 1 unit of space. If you fill the box completely with cubes, you can count how many there are and tell me the volume. So let's do this together. If there are, looking at the picture, we can count all of the cubes together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, to get a total of 24 units for the cube's volume. Now, instead of counting all of the cubes individually, an easier way we can find the volume is counting layers. So as you can see, there are 12 cubes on the top layer. And in this cube, we can do 12 cubes times 2 layers to get the volume of 24 units. The two key principles include the movement principle, which is the concept that geometric figures can change position or orientation while keeping their same properties like size and shape. The additivity principle is if you combine a shape into smaller, non-overlapping parts, the total area is the sum of the area of those parts. This is A plus B equals AB, or the additivity principle. Looking at the clay Play-Doh shapes on the bottom right picture, even though the clay can be pushed or stretched, the amount of clay stays the same, right? So the volume stays the same too. Means nothing is added and nothing is taken away. This is important because sometimes shapes look different, but they can still take up the same amount of space. Now we're looking at shearing and Cavalari's principle. Shearing believes that sliding thin slices of a solid without stretching it. And Cavalari's principle is if two solids have the same height and the same cross-section at every level, they have the same volume, even if it is tilted. Now looking at this stack of paper, if you push the stack sideways and it starts to lean as it is here, the shape may look different, but nothing was added or removed, so the volume doesn't change. This is a way to help us understand that even if a shape is slanted, the volume stays the same if the base and the height stay the same. Now we are ready to look at the prisms and cylinders formula. For prisms and cylinders, we find volume by multiplying. This is the area of the base times the height. This tells us how many cubes are in one layer, and the height tells us how many layers there are. So if the base has an area of 6 units and the height has an area of 4 units, to find a volume you have to do 6 times 4, which equals 24 cubic units. These are oblique shapes. Sometimes shapes can lean to the side like these are. These are still prisms or cylinders, just tilted. Do you think the volume changes if they lean? No, the volume stays the same as long as the base area and height stay the same. Even leaning shapes hold the same amount of space inside. Now let's look at these shapes. Pyramids and cones come to a point at the top. They get smaller and smaller as they go up. If a pyramid and a prism have the same base and the same height, the pyramid's volume is 1/3 of the prism's. Same thing for cones and cylinders. So if a prism has a volume of 90 cubic units, the pyramid with the same height and base area would have a volume of 1/3 of 90, which equals 30 cubic units. Looking at this as a formula, it is height times area of the base times 1/3 to get the volume. When finding the sphere volume, the formula is 4 divided by 3 pi r cubed, r being radius. This makes sense because it is a 3D measure, which uses r cubed. Related to circles, it involves pi. It comes by comparing a half sphere to a cylinder with a cone removed. Now, let's look at spheres, or balls, or bubbles. They don't have a flat base, but volume still means the same thing. How much space is inside a sphere? Now, we're not going to calculate that today, but we can compare it to other shapes so we can understand that a sphere also takes up space just as the others do. Before we start looking into water experiments, let's make sure we don't get volume and surface area mixed up. When looking at volume, it is the space inside of a shape, like how much water fills up a tank. Looking at surface area, it is the space on the outside of the shape, like how much wrapping paper covers a box. If you're filling a container with water, that is volume. If you're wrapping a present, that is surface area. These are two totally different ideas. Now let's look at the fun part, finding volume with water, or water displacement. If we put an object in water and it sinks, the water level goes up. The amount it rises tells us the volume of the object. An example of this would be water starting at 300 milliliters. After we put an object in it, it rises to 380 milliliters. The volume of the object, to find it, you have to do 380 minus 300, which equals 80 milliliters, which is the same as 80 cubic centimeters. So 1 milliliter is equal to 1 cubic centimeter. Let's look at something interesting here. Floating objects and Archimedes' principle. When an object floats, it does not push away water equal to its whole volume. Floating objects only push away water that weighs the same as the object. So, if you put a floating toy in water and the water rises by 80 milliliters, that means the toy weighs 80 grams. This idea is called Archimedes' principle. Things float when the water they push away weighs just as much as they do. Now, think about this question to yourself for a minute. When I slowly lower an object in water, will it sink or will it float? Give me a thumbs up if you think it'll sink and a thumbs down if you think it'll float. Okay. If the object is able to push away enough water so that the water it displaces weighs the same as the object, then it will float. But if the object can't push away enough water to match its weight, it will sink. That's why big metal ships float. Their shape allows them to push away a lot of water. Now it's your turn. Together, we're going to work on 3 of our own problems. First, if a box has a base area of 10 square units and a height of 6 units, what is its volume? Turn to a partner and discuss your answers. Okay, the correct answer for this problem is you would do 10 square units times 6 units. 10 times 6 equals 60 units. For our second problem, it asks if water rises from 250 milliliters to 290 milliliters when a rock is dropped in, what is the rock's volume? Turn to your partner and discuss. The correct answer for this would be 40 milliliters. To solve this, you would do 290 minus 250 to get a total of 40. Last, we have if a floating object makes water rise by 25 milliliters, how much does it weigh? The correct answer is 25 grams. To end off our lesson, I'm just going to go over some review of what you should take away from today's lesson. First, volume is how much space is inside a shape. We can find volume using cubes, layers, or formulas. Prisms and cylinders are base area times height. Pyramids and cones are 1/3 of their matching prism or cylinder. Water rising tells us the volume of sinking objects, and floating objects push away water equal to their weight, not their volume.